in example 8, the alternative hypothesis is the population mean is less than 270. And in this example 9, the alternative population hypothesis is mu is greater than 22. So this is a different situation. If we look at the previous example, if we want to test if the population mean is less than a number, and we convert x bar to z-value right here, convert x bar to z-value, and then we make sure this, if the z-value false is less than negative 1.96, which is the cutoff point z-value, then we support the alternative claim. But since this is bigger than, it's a different case. So we, first of all, the steps are similar. First, we want to find out the cutoff z-value, and for say 5%, 1%, 2.5%, whatever. So you can see this is the same as before, 1.645. And then we convert x bar, which is given here, to 23.5, and we convert that using this formula right here as before, and we convert to z-value 1.10. And when we compare the cutoff z-value and the z-value corresponding to x bar, so one is 1.10 and the other is 1.645. And because this case, we want it to be, if we want to support the alternative hypothesis mu is greater than 22, then we want the z-value corresponding to x bar to fall into this region here. So 1.10, when we compare 1.10, it does not fall in this region, black region here, interval. So 1.10 is actually on the left side of 1.645. So in this case, we cannot support the alternative claim mu is greater than 22, and we will support. So we will say that in this case, we will say we reject the alternative claim. Again, this level of significance is given. Test alpha. Alpha is the level of significance 0.05. So that number means the chance of making a mistake by rejecting the null hypothesis is 5%, or the chance of supporting H1 and mu is greater than 22 is 5%. So it depends on what the alternative claim is. So because in this time we want our x bar to be large enough in order to support this. So where is the cutoff for x bar, or correspondingly where is the cutoff for z value? So we want the x bar to be big enough in order to support it, but our x bar apparently is not big enough to support the alternative claim, because 1.10 corresponds to x bar 23.5. It's not big enough to reach the cutoff point 1.645, which corresponds to the cutoff value for x bar. Okay, so we have three cases. One is mu is less than a number. This case, mu is greater than a number. And next, we're gonna look at a case that mu is greater so we have one case less than, another case greater than, one more case is not equal to. So it means either greater than or less than. Okay, so we can look at this example here. We have 40 observations, and this time our claim is not greater than a number. Our claim is saying the alternative hypothesis is mu is not equal to 2.6 hours. And so somebody says the average number of hours for the students serving in the community is not exactly 2.6 hours, and you want to see if it is, it's either yes or not. So if the alternative is not, then the null hypothesis H0 mu is equal to 2.6. By the way, we use H0 for null hypothesis. We use H1 for alternative hypothesis. The alternative hypothesis is always the claim you want to test. Okay, so the sample size is 40, and again the steps are the same. We found the cutoff point, and then we convert the x bar to the corresponding z value. So in this case, since mu is not equal to 2.6, it's equivalent to say mu is either bigger than 2.6 or mu is less than 2.6. So if we want to support H1, the alternative claim, we have two regions now. So it's either big enough, so x bar is either big enough or x bar is small enough. So we can look at how we do this. Yeah. Okay, so that's the region. Again, the level of significance alpha is given. It's 0.05. Since we're talking about the total probability is 0.05, and now we have two regions. So it's either here x bar, the value corresponding to x bar either falls into this region here on the right side or the region on the left side right here. So what we do is the total area is 0.05. That means because they're symmetric, so half of it is 0.025, and then we will find the corresponding cutoff point, z value 1.96, negative 1.96, and then so first step found the corresponding cutoff point. But be careful this time that we don't use the alpha value level of significance. You have to divide that by 2 because we have two sides now. Not equal to means it's either greater than or less than two sides. In example 8, less than only the left side. In example 9, greater than, we only have right side. But this is not equal to means it's either greater than or less than. So we convert the x bar 4.55 to z value 2.39, and you can compare this z value with the cutoff point. Does 2.39 fall into one of the regions, one of the intervals? And you can see it falls into the right side. 2.39 is bigger than 1.96. So if it's bigger than that, it means it's greater than this value. So we can support the alternative hypothesis. If we go back here, it's this one here. Mu is not equal to because it's greater than. So then we say we support this claim, alternative claim. So okay, so that's how we do these 3 different cases.